Acids and bases are electrolytes, and they can be divided into strong and weak electrolytes. Now, we probably don't have to show the importance of acids and bases in chemistry and in medicine, but you do know that acids and bases are critical components of your blood, of your stomach, of all kinds of reactions in the biochemistry of your body. So let's begin with the definition of acids and bases. Let's begin with acids. So acids are defined as substances that ionize in aqueous solutions to form hydrogen ions. So aqueous solutions to form hydrogen ions. So the word ionize means they form ions. That's what the word ionize means. So remember, ions can be positively or negatively charged particles, right? So if you have something like HCl and you dissolve that, it says it's a gas, hydrogen um, chloride gas. And if you dissolve that in water, that's the word aqueous, it will form hydrogen plus and chloride ion. So here it is. Here's your acidic component. This is your hydrogen ion, and we actually like to call it a proton. The sooner you use the word proton, the better. In fact, this is why in the stomach, we call some cells that actually produce the hydrogen ion proton pumps. So these are acids. They can produce hydrogen ion in aqueous solutions. Bases, on the other hand, they accept hydrogen ions. And to make it simple, because we're really in a basic chemistry level, when dissolved in water, they produce OH minus ions. So if I have sodium hydroxide, it's called lye, used in making soap and all kinds of industrial processes. It will ionize to produce Na plus and hydroxide ion. So this is what we call hydroxide. Now again, this is in stomach, right? This is stomach acid. Now again, this is a brief definition. Let's talk quickly about strong and weak acids and bases. So acids and bases that are strong electrolyte, meaning they dissolve completely or almost completely, are called strong acids and bases. And here's the list. You should commit math to memory, because once you know these, then everything else is considered weak. So you have hydrogen chloride, bromide, hydrogen iodide, you have chloric acid, perchloric acid, nitric acid, and sulfuric acid. Strong bases are sodium hydroxide, lithium hydroxide, potassium hydroxide, and group 2 hydroxide, which are strontium hydroxide and barium hydroxide. So again, acids and bases that are weak electrolytes are weak acids and bases. So this is a strong electrolyte. Therefore, it's a strong acid. 100% dissociation. Same thing with sodium hydroxide. If you have something like, on the other hand, if you have something like HF, which is not one of these in the list, then this would be a weak electrolyte, which is a weak acid. So you have less than 5% dissociation. Very well. So we have something called neutralization reactions, and this happens when you combine an acid and a base. And when you combine an acid and a base, you produce water and salt. So if I bring now the strong acid, in this case, hydrogen chloride, combine it with sodium hydroxide. So this is your acid, this is your base. They will neutralize each other and they will make water and salt. In this case, table salt. It doesn't have to be table salt, of course, depending on which acid and which base you're using. So notice that you're producing water, and this is why it's a neutralization reaction, is because water is neutral. We're going to learn that in the pH scale in a second. Same thing, here's a strong acid, here's a strong base, and you produce salt and water. Be aware that the word salt in chemistry doesn't mean table salt. Salt means an ionic compound, which is the positive and negative.